Hello guys, welcome to online video tutorials, and we are learning about Siemens S7-1200. In today's video we'll see about the timer operations. So we have various timers in the PLC, and timers are required when you want some delays in your operation, when you want to include some delays, or you want to have some sequential operation with a time delay. Okay, when you have some several sequence which you want to initiate at different time, we use some timers. So we have various timers in our Siemens S7-1200. The first one we are going to learn about is pulse timer, and then we have an exercise example. So this is the block diagram of a pulse timer. So let's understand its details. So it says pulse timer generates a pulse with a preset with time. Okay, so there are three keywords: preset, with time. What does it mean? If you see, this is a block diagram, and here we have a data block. This is the address of a data block. Now what is a data block? Data block is a block which stores the parameters of this timer. Okay, it stores the parameters like how much is the preset time. I will tell you what this preset time is, and what is the status of the input, the status of output, and the status of ET. Okay, so this data block, you can understand, it's a memory which stores its parameters so that we can access that later on in our program. So we have a lesson of changing the parameters or accessing the parameters of a timer, in which I will explain more about this data block. So this is the address, and that's the name of data block. You can also give your own name. You can write it as TP1 or TP2. You can give your own name to this data block. Okay, so here we have the input. Now this timer will run. This will generate pulse if it has some input at its back. Okay, the time you give the input, it will generate the pulse. So input required from here is, you need generally 0 to 1 signal. So you need a signal like this to generate the input. So this transition, positive transition, is required this timer to start. Okay, and this is the preset time, T1S. Now this preset time is 32 bits, which means you can have time up to 32 bits limit. 32 bit is like 2 raised to the power 32, and the value which comes is the range of this timer. Or in other words, to make it easier, it can store time up to 24 days, 20 hours, 31 minutes, 23 seconds, 647 milliseconds. That's the range of this timer. This is the maximum time you can give to your pulse timer. Okay, and the giving time is very easy. We will see that in the example. Like if I have to give 1 second, I'll just type 1s and you will have 1 second. If you want to give a time of 1 minute, you just put 1m, it will be 1 minute. If you need 1 minute 20 seconds, then in that case you can put 1m. If you need 1 minute 20 seconds, you can put 1m and underscore 20 seconds. So this will give you 1 minute 20 seconds delay in this one. So it's pretty easy. Then you have the current time. Now the current time means when you start the timer, this will show you the current time, how much time it has already executed. Okay, and then you have the output. Now what will be the output signal, how the output will come, how the pulse will be generated? Let's see that in a diagram. So we have example, if preset time is 1000 milliseconds or 1 second. So if you give here 1 second, how the timer will behave. So have a look at this diagram. Now this is my input. So this green part, this is my input, and this is my output. Okay, so what will happen when you initiate the input? So when you give the signal here, this is my output, the output will be on. Okay, it will on immediately the input comes, and it will be on only for the preset time. So this time will go to the output, and output will be on for 1 second. So this is 1 second, and then it will be off automatically even if the signal is on here. Okay, the input is on here, but the output will be off because the preset time is over. So if you give the preset time as 3 seconds, it will be on for 3 seconds. So this is the time for which you want your output to be on. Okay, now it doesn't matter if the input signal is smaller than the pulse. So in this case, if you see here, if the input pulse is smaller than the preset time, in that case as well, output will be on for 1 second. It just need a negative to positive transition. This edge is required. Let me take another color to explain. Yeah, just this part of the signal is required. The positive edge is required for this timer to work. So it doesn't matter if the input pulse is more or smaller than the preset time. But now, once the preset time has started, once the output is on, even if you give a pulse in between, this will not affect the output. Okay, this will still run for only 1 second. It will not like it will go for 1 second from here and go up to here. This is incorrect. This will just complete the pulse and it will go off. If you want another 1 second time, you should give the signal once it's off. So if you give the signal here, then it will be on for another 1 second. So that's the pulse timer to generate a pulse. Now you can use this pulse timer to generate different pulses or continuous pulses. We'll see that in the exercise, but first I want to demonstrate that in S7 1200. So let me open my main logic where I can show you a demonstration. And in the example of this pulse timer, we will have a look. Let's just preview the example. In this example, okay, we have some did you know fact. Changing PT has no effect while the timer runs, as I explained here, that when the timer is running, this pulse will complete even if you change the preset time while this timer is running, while the pulse is running. If you change this PT, this will not affect the pulse. Changing in has no effect when the timer runs. This explains here that if you change the in once it's on, if you turn it off or turn it on again, this will not affect the pulse timer. So once the pulse starts, it will execute and then it will end. Okay, we have an exercise example which we'll see after a demonstration. It says write a logic to generate continuous pulse output at Q0.0. Consider pulse time to be 1 second. Now in this case, we need on-off pulses. Okay, but we have learned that we can generate only one pulse with one input. How we can generate multiple pulses automatically, that is the logic we have to design here. Okay, so let's first understand this. Well, the Siemens S7 1200, it's a bit slow because it needs a lot of memory in your computer. So don't worry, you need to have a lot of patience while working with S7 1200 if you have an average computer with 6 GB of RAM. Okay, so this is started. So what I'm going to do is I'm going to take one input here, and this could be of my first address. So I will take I0.0. This is my tag 1. Let it be tag 1 by default. And I'll take a timer. So timer will come from this block. So you take TP, generate pulse. You just drag and drop here. And this is the data block. As I told you, this is the name, so I can change the name to TP. Let it be automatic and press OK. So this is TP. Now the pulse time I will give 1 second. So just put 1S and press enter. So your time is here. ET, it's up to me if I want to display ET or not. If I want to monitor my ET, I have to give a data register. So in this case, I'm putting MD0. Okay, this is my data register in which I can see the time. So you can use MD1, MD2, it's up to you. Okay, now at the output, I will take an output coil Q0.0. This is my tag 3. So that's how I can, this is how you can simply generate a TP which will generate a 1 pulse at the output, and which we can see in our PLC. I have set up a camera for you. So let's download this logic. And for downloading, I have to configure my hardware. So you can also review how to configure the hardware. For that, you need to plug in your Ethernet port. So let me just try it again. Cancel. Yes. So you'll start search, and it will search your PLC. So once you got your PLC, you need to just select it and download. So I have my PLC here. It says CPU 1212 AC detect. It will take a couple of seconds, but this is just for once. Then you can download continuously. Okay, so the program is compiled. It's compiling and preparing to download. So I need to stop my PLC before it downloads, because this is mandatory. It's loading configuration. It'll take some time. The program is downloaded. Finish. Okay, so the program is downloaded now. I will go to monitoring, and my program is in monitoring mode, and here is the PLC. So I will put it here, and okay, I'll put it here. So I'm going to turn on my first input. So this is my first input, and that's the first output. So you will see that if I turn on the input, output will be on for 1 second. Okay, so let me just keep it here. So here goes my input, and output is on for 1 second, and then it's off. Okay, so let's try again, because this was pretty quick. I turn it off, I turn off my input, and I start my input again. Output goes on for 1 second, and then it goes off. Okay, so this is the basic of how pulse timer work. I hope this is pretty clear with this small demo example.